Consider the equilibrium equation for a buffer created from a weak acid. So the acid dissociation constant can be written as follows. And taking a minus log on both sides, we obtain pKa on the left. And now we can apply the rules for logarithms to break up this log and this term here is the pH. So we can write the expression relating pKa to pH as follows. And this equation can be rearranged to relate pH to pKa. And this is the Henderson-Hasselbalch equation. So adding small amounts of acid or base to a buffered solution does not significantly change the ratio of the conjugate base to the acid, and therefore won't affect the pH much. Now, in a similar way, you can relate pOH to pKb using the equilibrium equation for this buffer created from a weak base. And in the reverse reaction, we can also write an expression relating the pH to the acid dissociation constant of the conjugate acid. Find the pH of a solution that's formed by mixing a weak acid with a strong base. So this neutralization reaction can be written as follows, which yields a salt and water. So the number of moles of the weak acid can be calculated from the given values. And for the strong base, and therefore the molar concentration of the excess weak acid in the solution is the difference in the number of moles over the total volume of the solution. And if we write this in the form of the net ionic equation, while eliminating the spectator ions, we see that for every mole of the base that was consumed, 1 mole of the conjugate base was produced. So the molar concentration of fluoride would be 0.05 moles over the total concentration of the solution. And therefore, because we have a weak acid and strong base reaction, we have a buffer, so we can use the Henderson-Hasselbalch equation to calculate the pH without the use of an ice table. And noting the buffer reaction is written as follows. So if we make our substitutions, pKa is minus log of Ka, and we have the molar concentration of fluoride over the molar concentration of hydrofluoric acid, which gives a pH of 3.3. So as expected, the solution is acidic, given there's excess weak acid in the solution.